Okay, so you've been using the distributive law to factor and to multiply. And in the last problem set, you use it to simplify. We're going to keep on going with that idea. Try these problems first. Let's practice factoring a little bit here. Because we're going to, at the very end of the problem, they're going to ask you to factor your final answer. So go ahead, hit the pause button and factor these. Okay, so when you factor, remember you know two ways to factor. You can use the distributive law if you have more than one term, but if you only have one term, you can factor using primes. That's important. And it's also important to remember what it means. What are you doing when you factor? You're writing it as a product, right? You're writing it as a multiplication problem. Good. Do you have to use the distributive law on this first one? The answer is yes, because they're not like terms. I would take out the greatest common factor, which is 4x, and what you have left is 2a plus negative 3y. And you can always check by multiplying back through. In part B, did you remember to always look to combine? Always look to combine like terms. Even though it doesn't say that, that's one of these like rules you should always be thinking about. Always combine whenever possible. Furthermore, with the commutative law, you can write these products in different order. If you always write them in alphabetical order, think of this as negative 3xy. If you write things in alphabetical order, it's easier to recognize that they're like terms. Oh, I made a mistake. This should be negative 4xy. God, I do that sometimes. It's tough being human, isn't it? Sometimes making mistakes like that. So the final answer is negative, I wrote it as negative 1 times 2 times 2 times x times y. There you go. All right, on this one, did you, same idea, did you recognize that you got some like terms here? If you switch the order and write this in alphabetical order, this is negative am plus negative 7am is negative 8am. Then your greatest common factor, I believe, is 4m, and you get 4m times the quantity negative 2a plus 1. This one you can factor, but you don't use the distributive law. It's one term, you just use primes. I like to break off the factor of negative 1. That's nice for next chapter. We're going to be doing that. So, and then 102 is 51 times 2, and 51, that's a triple 17 in darts, isn't it? 51, a triple 17? 51 equals 3 times 17, so there's your final answer. This is factored because it's written as a product. This is factored because it's written as a product. You see that? That's really important that you see that. Okay, so on these problems here, what we're going to do is we're going to, just like before, we're going to simplify using the distributive law first to multiply this out. But at the very end, it says factor your final answer if possible. So talk to your instructor about how they want you to write it. But in my class, when I say factor your final answer, I mean completely. If it's one term, I want it to factor into primes. If it's more than one term, I want you to factor out the greatest common factor. Okay, but talk to your instructor. They might want you to write it slightly differently. All right, so we first use the distributive law carefully. Make sure you multiply each of these terms by 3. And remember, you drop the parentheses when you use the distributive law. Then I'm going to combine the 21 plus the 3 and get 24. Now I look to factor at the end, you see? As a general rule, you don't have to factor unless it asks you to, okay? If the instructors say factor your final answer, then you're not done. But if it doesn't say to factor your final answer, you can leave it like that. The greatest common factor is 12. So I take 12 out and I have negative x plus 2. That's my final answer. It's factored because it's written as a product. Very good. You guys are really good. Better than usual, I would say. Better than most quarters. All right, this one. What should we do first here if we want to simplify? Can you combine those? Yes. Now those are alphas. Alpha is kind of like an A and a beta is kind of like a B. Anyway. So when you combine negative 4 alpha plus alpha, you get negative 3 alpha. Now we don't use the distributive law, we just multiply. We get negative 6 alpha plus 3 beta. Now it says factor your final answer. Would you use the distributive law here? I think you would, because these aren't like terms. You take a 3 out, your final answer is 3 times negative 2 alpha plus beta. A couple more, then I'll give you some to practice. How about that? So to simplify and factor your final answer, we work inside the innermost parentheses. Can you combine those or those? No. So the first step we're going to do is we're going to multiply these out. We're going to use the distributive law here. And here, remember, this is a negative 1. So the negative 1 has to multiply each term just like the 5 does here. So when you carefully multiply it out, you get 5z plus negative 5w. Here you get negative z plus negative 3w. Combine the z's. I get 5z plus negative z is 4z. and negative 5w plus negative 3w is negative 8w. Factor out the 4, that's the greatest common factor. 4 times the quantity z plus negative 2w. And I know I say this a lot, but you're more than welcome to hit the pause button whenever you want and try these on your own. You'll get a lot more out of it if you try it and then use my video to check your answer. You'll learn a lot better that way. Let's see. Inside the innermost parentheses, can you combine those? No, not like terms. So the first step we're going to be able to do is multiply the negative 2 by each term. And when you do that, you get to drop those round parentheses. You don't get to drop the square ones though, right? Just these round ones. So you get this. You get negative 2 plus negative 2y inside the parentheses. Now we're going to combine the y's. I get a negative y plus negative 2, but I write the whole problem down just like we were talking about all quarter. Then I'm going to use the distributive law one more time, multiply each term by 4, so you get this. Almost done. When you combine like terms, I believe you get negative 6y plus negative 8, and you can factor out a negative 2. Okay, a couple more, then I'll give you some to try. Now this one, is there anything you can combine inside the parentheses? No, those are not like terms, those are not like terms. So we're just going to have to use the distributive law carefully. We distribute the negative 2 to each of these, and we get negative 6ab plus negative 10b. And you distribute the 4b to each of these. 4b times 3 is 12b. 4b times negative a is negative 4ab. Now look at this. Are there any like terms? I think we can add the ab's together and get negative 10ab, and we can also add the negative 10b plus the 12b and get 2b. And since it asks us to factor our final answer, the greatest common factor is 2b. When you take a 2b out of this one, what do you multiply 2b by to get negative 10ab? The answer is negative 5a. You have to have a 1 here. It would be easy just to put 0 here, but that's not right. If you don't have a 1 here, what do you multiply 2b by to get 2b? The answer is 1. But if you don't put a 1 there, it's going to be wrong. When you multiply back through, you're not going to get it. Alright, this last one's kind of tricky. We're working inside the square brackets, and we see y plus 1. You can't add those. So the first thing we're going to do is use the distributive law to multiply that out. Now, you also see this 2x over here. Let's not worry about that. Just keep it there for now. So when you multiply this out, you get 2y plus 2. Inside the square bracket still, can't we combine the y's? So this is where we're at. We're down to here. Now, this could throw you because you haven't seen this before maybe. Read it back. 3 times negative y plus 2 times 2x. Those are 3 factors, right? We're going to multiply these 3 things out. Now, you can multiply any 2 you want. One way to do it, this is not what I would suggest, but here's one you could do. If you multiply the 3 by each of them, but you don't get to drop the parentheses because the 2x still has to multiply each of them. So if you distribute the 3 and then distribute the 2x, that's one way to do it. And then on the last time, you can drop the parentheses. But what I'm going to do? I'm going to multiply the 3 times the 2x first. You can do that. You can move these around. So if you multiply the 3 times the 2x and get 6x, then I can distribute the 6x through. It would be negative 6xy plus 12x. But wait a second. It says factor your final answer. As soon as you do that, aren't you going to want to factor it? Guess what? You would go right back in a circle. So this is, if you think about it, this is actually the final answer. If you want to multiply it out and then factor it again, go right ahead. But this is what you're going to end up with. Alrighty then. Alright, so why don't you go ahead, hit the pause button, try these. The instructions say to factor your final answer. Okay, let's go over these. So in these problem sets here, we're really using everything we've learned the whole quarter. Factoring, multiplying with the distributive law, adding like terms, the order of operations. So if you can do these problems, then that pretty clearly shows you understand everything we've talked about. Okay, when you simplify, a good practice is to look inside the parentheses and ask yourself if you can combine anything. No, they're not like terms. So we use the distributive law here. Multiply each of these terms by negative 2. We multiply each of these terms by negative 4. You get negative 6x plus 12y plus 36y plus negative 20x. We can combine the x's. I get negative 26x and 48y. And then the greatest common factor looks like it's probably just 2, I think. 2 times the quantity, negative 13x plus 24y. Now over here, let's see, this one, it's kind of messy, all these alphas and betas. This is negative 4 beta alpha times the quantity 2 plus x. Inside the parentheses, I don't see anything to combine here or here, so we're going to multiply each of these terms inside the parentheses by negative 4 beta alpha. So the first one becomes negative. I write it in alphabetical order. So it'd be negative 8 alpha beta. That's what this first term becomes. And this becomes plus negative 4 alpha beta x. Over here you get negative 6 alpha beta. And this becomes plus negative 4 beta x. I think these are like terms. This and this are like terms. That's the only like terms. Because this has a beta x. This has an alpha beta x. So these are not like terms. What do you get when you add those together? You get negative 14 alpha beta. You just got to leave this as negative 4 alpha beta x plus negative 4 beta x. Yeah, what's the greatest common factor here, though? There's something like a 2. Anything else? How about a 2 beta? So that's your final answer. 2 beta times the quantity negative 7 alpha plus negative 2 alpha x plus negative 2x. You could have also factored a negative 1 out of each term, and that would change the sign of each term inside the parentheses. On these last two, let's see. What would you do first on this one? Did you recognize you can combine the b's inside of here and the a's inside of here? It just makes your work a little nicer, I think, a little easier. Then I think we're going to have to use the distributive law on this first one. We'll multiply each of these by 2a, and here you just write this as negative 8ab. So when you distribute the 2a, you get 12ab plus 10a plus negative 8ab. You can combine the ab's. These are like terms. The first and last are like terms. So you get this. Now what's the greatest common factor? I'm going to say 2a. 2a times the quantity, 2b plus 5. Okay, last one. So here, we work inside the innermost parentheses. Can you combine the negative n plus 1? No. So by the order of operations, what would the next thing you would try to do would be? It would be to, inside these square parentheses, you'd multiply this out. Rewrite everything else the same, right? Negative 9m plus 3 times the quantity of 2m plus, and this becomes negative 5m plus 5. Then you combine, inside the square parentheses, combine the m's. Now we're going to distribute the 3 to each of these, so you get negative 9m plus negative 9m plus 15. We can add the negative 9m's and we get this. So are we done? No, the instructions say factor your final answer if possible. I believe you could take a 3 out. So there it is. 3 times the quantity, negative 6m plus 5. Okay, and the next problem set we're going to keep on going. So problem sets 18 and 19 are pretty, 17 and 18 are pretty similar. So we're going to keep practicing this. If you're having trouble, don't worry. Just keep doing the homework. You'll get it. See you later. Bye.